Hello friends, today in our class on set we'll be taking a look at the Venn diagram. The Venn diagram. Alright, so the Venn diagram is the graphical representation of sets. Okay, the Venn diagram is the graphical representation of sets. Graphical representation of sets, that is what the Venn diagram is. Alright, so it shows the relationship between two or more sets. So I would want us to just to go through these diagrams we have here. But before then, let us take a quick look at something before we go. So now let's look at something. A Venn diagram, we may have a set. Let's say that's set A, this is set B, this is set A, and this is set B. All right, so in this case, what we have here, okay, what we have here is what they have in common. So we say that is, if we remember our class on intersection, complement, and union of a set. So what they have in common is the intersection. So we go ahead and say this is A intersection B, okay, A intersection B. That's what that represents. So usually we love to put it inside a rectangle like that. This rectangle is the universal set. Okay, the rectangle is the universal set. All right. So now let's look at something. If we have a universal set like so, and we have P and Q, we have set P, we have set Q, and we have this. All right, here we can see that everything is shaded, so that means everything that is contained in both A and in both P and Q, that means that would be P union Q. All right, that would be P union Q. All right. Now let's see a case where we have this, then we have this, this, okay, 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 okay. That is outside. We have outside shaded. So this simply means that the required part is the side outside. That means any other thing that is contained in the universal set but that is not contained in either M or N. Okay, it's not contained in either M or N, but it is outside. It is contained in the universal set. I know you're thinking now, of course. That means we are talking about the complement of the set. So we have set M and N union N. Okay, all right, complement. So it simply means that we are cutting out M and N from the universal set. So that's why that place is shaded. Okay, that place is shaded. Now let's see, what if we have a set like this, or a diagram like this, where we have this one, we have this one, then of course we have maybe we have set X here and set Y here, then we have shaded is this one. Okay, shaded is this. All right, so if we look at this, it almost looks like X union Y, but the whole of Y is cut out, so we put Y complement. Okay, Y complement. So that would be X union Y, where Y is complement. So that's exactly that's the basic diagrams we will see when it comes to. So if to apply our knowledge in this one, let's see, we have W and R. So let's see if we can get W union R. Let's see what that would be. W intersection R. Okay, let's say union R complement first. Then let's see what that would be. Then W intersection R. Let's give us. Then okay. So okay, what of the universal set? Let's say the universal set, okay, is E. Okay, universal set, which is E, is equal. So let's see this. So let's see the sets. This will give us. All right. So in W union R, okay, in the universal set, that's everything contained inside the rectangle. Okay, it doesn't matter where it is, everything contained there. Of course, we have 5, we have another 5, we have 10, then we have 10 again. Okay, so I know you may be thinking, why are we repeating 5 and repeating 10? So this is not like the set where said earlier that it's make sure that every member of a set is unique. So not having A, then B letters of so what of W's contained in both W and R. If we check, we have 5. We have this 5 here. We have this 10 here. We also have this 10 here. That is all. So W union R complements. That means what is contained in both of them, we want to cut it out. So if we cut away what is contained in both of them, then we will have that W and R cut away. That means what will remain will be this one. 5. Okay. So what is W intersection R? What they have in common? So which is this place? All right. So and that's our 10 here. That would be 10. So we've been able to dissect that particular set. Okay, we are dissect that particular set. All right. So, but if we see, you know that W is not, okay, is not a subset of R. Neither is R a subset of W. So, but they are both subsets of the universal set. Okay, every set contained in the universal set is a subset of that universal set. All right, let's look at this one. Here we have E, the universal set, the C, the set outside, then the set inside. Okay, it's not labeled, so let's label it as S. Okay, let's say that is set S. All right, so let's see. The universal set is E, and what is that? It's 0, 1, 2, 3, 4, 5. That would be 0, 1, 2, 3, 4, and of course 5. Okay. Then set T is everything that is contained here in T. So, and that will still be 0, 1, 2, 3, 4, and 5. All right. Then set S is 0, 1, 2. It means that set S is a proper subset of set T. Okay, set S is a proper subset of set T. All right. So now, what else can we say from this place? What of the set S union T is everything contained in subset of is a subset of T. Then what of the complement outside outside, there's nothing within the universal set that is not contained in S and T. So that will be an empty set. So we write it that way, or we just put the phi, okay? So that is that. Now let's see this one. This one says that we have sets A and B, set A and B. So let's first take the universal set. Universal set is 0. I have 0 outside there. Then there is 1, 2, 3, 4, 5. Is there 6 here? 7, 8, 9, and 10. Okay, I guess it's 1, 2, 3. So we don't have to write everything. Dot, dot, dot. Okay, then we have 10, which is the last member of that set. So from this place, we have set A union B. It's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have 7. We have 9. So that's set A union B. What of set A intersection B? A intersection B. That's what they have in common. Okay, what they have in common, which is 1, 3, and 5. That will be 1, 3, and 5. Okay, 1, 3, and 5. So what of A union B complement? A union B complement. A union B complement will be A union B, everything contained within A and B. We want to cut it out of the universal set. So if we cut it out of the universal set, then the value that will remain will be what you have outside. That will be 0, 6, 8, and 10. We have 0, 6, 8, and 10. Okay? 0, 6, 8, and 10. Then, let's quickly do something. And what of if we are to look for A union B, B complement? That means we're looking at A union B, what we have in both A and B, but we are cutting B away. So if we cut B out, okay, if we cut B out of A union B, it will remain 7 and 9. So what will be left will be 7 and of course 9. All right, so that would be equal to 7 and 9. Okay, so whatever we are asked to do with this set, whatever it is, it's totally to us. So if it's the Venn diagram, this is the introduction to Venn diagram. So I'm going to stop here now, then we'll treat problems on Venn diagram, word problems later. So thank you for your time. Have a nice day.